Well, I want to thank the IESA organizers for inviting me to this. It's quite an honor to be here. What I'd like to talk to you a little bit about this morning is, we heard a lot of great things earlier in the day about all the amazing initiatives that are happening for Digital India. So I want to talk about, not just all the data that's generated, but how do we store it and use it. Okay, so a couple messages that I hope you end up taking away with today. The first is that data is being generated at just a phenomenal rate. And we'll show you a little bit about that, and I think you all know that just from your daily experiences. The other thing is that the value of data is incredibly high. So, there's statistics that show the company who actually use their data, be it for marketing or analyzing their manufacturing processes, really return better investments to the shareholders. And there's a huge opportunity for determining how, as India becomes more and more digitized, how that data is stored and used and what devices are being used to store it. And then lastly, just about Seagate, some of you might not know, but I'd like to show you a little bit about our range of products and how we fit into this infrastructure to support Digital India. And hopefully you'll get the sense that we're extremely innovative, we have great people, we have a huge product scope, going from the fastest data storage devices and PCIe accelerator cards to archive hard drive systems, and that we have huge manufacturing scale to be able to accomplish some of these huge tasks that are before us. So first on the agenda, let's talk a little bit about data trends. And there's a million statistics about how much data is used and being generated. And this chart just shows some things that might happen in an internet minute. So 300 hours of video get loaded up to YouTube every minute. Over 4 million people respond on Facebook. Well over 4 million do a Google search in a minute. So just huge amounts of data. But I think it's a little bit easier to get the sense for this with a picture. So here's a photograph of when Pope Benedict was installed at the Vatican in 2015. So just a little bit, or 2005 rather, a little bit over 10 years ago. And then here's a photo in 2013 when Pope Francis was installed. And I think you can tell that just in that short time, less than a decade, there's a huge amount of mobile devices. And I see a bunch of them out there today. So, where people are creating content, sharing content, looking at data and content, and communicating in a social way. So this in itself just generates a huge amount of data. Oh, there we go. Okay. So, as we mentioned, the data sources are increasing, and we showed one there with mobile devices and consumers using social media in different ways. We heard a little bit this morning about the Internet of Things and how that is growing. Many, many devices are having different ways to communicate with each other. So there's a lot of machine-to-machine communication. I actually recently heard about some light bulbs that actually are connected to the Internet and transmit data. And maybe we could have used one this morning to transmit a little data. But it's just an amazing amount of ways that data is being created, and people are finding different ways to use it. So as I mentioned, big data analytics is an extremely important vehicle for analyzing trends, be it they market trends, healthcare trends, or genomics, weather trends to look at climate change and the like. But with all the data that's being collected, people are finding ever more ways to use it. And another important thing that we probably won't touch on here, but it's the security of the data. As we get more and more personal data loaded, people obviously want to feel secure about it. So that's a whole nother topic in itself that I won't be touching on today. But some of the facts that we mentioned, companies rather, who use big data are twice as likely to be in the top 25% of financially performing companies. So there clearly is a value that one can deliver to shareholders or the particular research project that you're under. So let's look at some growth, about just how big this big data is. So there's a bunch of numbers on here. Basically, if you look out at the end of the decade, predictions by IDC and others would assume that 44 zettabytes will be the amount of data that's created. So a zettabyte is 10 to the 21 bytes, for those of you keeping score. And you might hear some words like exabyte in the talk too, which is 10 to the 18. And there could be a quiz later on what comes after zettabytes, but you can get your mobile device and look it up while I'm talking. The amount of data that'll need to be stored is about 13 zettabytes. But the amount of data that an industry, worldwide industry, be it hard drives, tape, optical, solid-state devices, is going to be able to store is about 6.5 zettabytes. So obviously there's a gap, and that's one reason that we need to be smart about how we use and store the data and what kind of devices and what's the best way to gain all this value that we'll get from it. Because we're having explosive growth in the data, as we've seen, but IT budgets are not growing at the same level. And I think that will be very important as India becomes more digitized, and that we have to be very smart on how we use our dollars to get the right amount of storage. Now, there's also an interesting shift in data that's happening. So if you look back at the start of this decade, about 2/3 of the data was shipped into the client market. So that would mean like your laptop or your desktop or something where the data was locally resided with the client. Now, if we shift to 2020, at the end of the decade, see there's basically been a shift where close to 60% of the data will be stored in the cloud. And only about a third of the data that's generated will still be stored on client devices or close to you. You also see growth in consumer electronics, so like digital video recorders, games and the like, and then smartphones and tablets. So the hundreds of millions of devices will account for some small sliver of that data. But you can see the vast amount of data being stored is on solid state and hard disk drives, majority of that in hard disk drives, and the majority of that is moving to the cloud. And this becomes extremely important for this really bold concept that we talked a little bit about this morning, Digital India. So this is, I think, truly a visionary idea that's combining a lot of the digital collection of data and use of data from various government ministries and the like and departments, and really trying to act as an umbrella organization to look at or corral all these different initiatives that were talked about this morning, like broadband highway or personal data, as we talked about, and being able to communicate financially different transactions. So all these various initiatives that are happening are in this umbrella organization of Digital India. And as I said, I think this really is a visionary idea, and it's a hugely complex idea. So first, from a technology perspective, being able to store this amount of data is a huge technical problem. It's got some really cool stuff happening, though, so that's fun from an R&D point of view. It's also a huge scale problem. So being able to scale this large amount of data that will be collected and used in a cost-effective way is another huge challenge. And that's really what I want to talk about for the rest of the talk today. So let's talk about applications. So there's lots of ways to store data, and I think a lot of you know that. You can have things that are very fast, but usually they are very expensive. Or you can have things that are not as quick, but come at a lower cost per terabyte. So this is a way that, or kind of the premise of what I want to talk about, is that you really need the right kind of infrastructure for the right kind of workload to be able to deliver a system that will give the user the experience that they want to, but at a cost-effective way. So it's kind of a few axes that we might want to look at. Maybe this is hard to see in the back, but I'll try to describe it. So along the y-axis, there could be a performance parameter. There's a cost parameter along the x-axis, and then going into the page, maybe a power parameter. And all the different types of data that you might use, be it flash or hard drives or some combination thereof, kind of go into a different part of this curve. And depending on the application, you might want to use different amounts of flash or hard drives. So kind of up in that top, that big red ball, would be online transaction processing. So that obviously you want something very fast, especially if you're a financial institution. You might not be as dependent on cost, and you probably can deal with some power. So in an installation like that, 10% or so of the storage that you'd use might be solid state. On the other hand, if you go kind of to the other end of the spectrum with something like archive, that one is going to be more power and more cost sensitive. So there you might want to use more hard disk drives. So depending on the type of workload, and there's clearly going to be lots of different workloads in a digital India scenario, you're going to have to optimize your data center to deal with these different amounts of data that's being used, generated, stored, and then you have to also consider the cost and power associated with those. So, another way of looking at that, from mobile applications all the way through the transaction processing as I talked about, or just a generic kind of data repository like Facebook or someone might have, through to the big data where we're analyzing all this different amounts of data, and then to high performance compute, which we'll talk a little bit more about later. You're going to have extremely different workloads, and you're going to want to optimize your systems in different ways. And this is an exciting time for the exciting time for architects in this business on how you do this. As I mentioned, back in the old days, it was really just you had your client compute, and then there was some enterprise data centers. So you'd have your PC, and the banks would have their data center, or the airlines or government agencies, but there really wasn't much in between. And today, there's just an explosion of different kinds of data that's generated in different ways that people are using it. We still have some of the ones that we mentioned about in the past, the personal and enterprise space, but there's also transaction processing. Surveillance is a huge application. That was mentioned a little bit in the smart cities, the video. And even at today's rate of video penetration into surveillance and the like, we generate about 550 petabytes of data a day with the video installations that are installed for surveillance. You might not have a good sense of what that is, but that's 11 million Blu-ray discs a day are generated just from the installed base that is happening today with surveillance, which certainly is expanding daily. Let's look at one little example here, the high-performance compute. So I think this is a fun example to look at. We like it from a technology perspective because, like in the race car, you put a lot of your point of the spear technologies, your really leading edge stuff into high performance compute. So it's great from a technology perspective where you get to develop this and then flow it down into other applications as time goes on, which helps improve performance, increase the capacity, and reduce cost. Another good reason to look at high performance compute is its storage itself is really the fastest growing space in the HCP arena. So maybe again a little bit hard to see, but storage was growing at about 10% through the rest of this decade, whereas the server part would be growing at about 8%. So it's clearly important, as I said, people value data, and the ability to ingest the data into an HPC system and get it back off so you can do all the data analysis is extremely important. There is going to be well, Seagate lights this not just for the growth, but our cluster store system, which is a specifically designed HPC rack system, is in 7 of the 10 largest supercomputers in the world. So this is, as I said, a space that is very close to our heart and some place that we like to keep working on. There will be a HPC panel discussion, I believe, tomorrow. So if you're interested in this, just a little bit of an advertisement for that session.